Good evening, everybody. It is once again Ted the Speed Learner. Now, in this particular presentation, what I'm going to do is I'm going to cover the proof for parabolas, and I'm getting this out of the calculus book written by Morris Klein. Now, what I have actually done here is I took Pappus Book 7, proposition number 238, and I superimposed the diagram of Morris Klein's calculus. Okay, and hopefully by doing this way, you can see that there is a very big correspondence. Okay, in other words, that the Pappus proof perfectly aligns with what Morris Klein was stating in his calculus book. If you turn to page 85, if you have the book, and if you don't have the book, I encourage you to get the book and look this up. It may be on a different page because he has different editions, but in this particular edition, I'm not sure which edition this is. Mine was the second edition, but if you get a more advanced edition, you may not be able to find this on page 85, but it should be pretty close. It should be in chapter 4. Okay, so anyway, bear with me on this. Alright. Now, they're defining a parabola for you. Okay? So, there is a certain set of points, and those points are right here on the actual parabola itself. And these points have to be equidistant. Now, what does that mean? Okay, so what that would mean is, in this particular case, it would mean that, this is just kind of a generalization. We're not going to get into specifics until a little bit later, but I would say that this point here and this point here would be pretty equidistant from each other. Or perhaps in this particular case, this point here would be just as equidistant from here as this point here would be equidistant from here. We'll get into the specifics of that in just a little bit. So that's just a generalization. We'll be more specific as we continue this particular video. Alright? So the points have to be equidistant from a fixed point. Okay? And a fixed line is a curve called a parabola. Okay? This is the fixed line they're talking about here, and this curve is going to be called a parabola, as Pappus established in Pappus Book 7, proposition number 238. And as you well know, I covered that in the previous video. Okay, now we're going to show you that there is a focus point, okay, and there's also a line which is called a directrix, okay, and I'll go into this as we continue this presentation. Alright, so what's the fixed point? Well, we're going to illustrate this with the letter F. This point right here, this is the fixed point, is also known as the symbol delta. It's right here. There's the fixed point. Okay? And D, the lowercase d, this line right here, which is also line AB, if you're following along with Pappus Book 7, proposition 238, this is the directrix. Okay? Then P is a point on the parabola. Okay? Okay, so they're talking about this point right here. This is the point on the parabola. Okay? And this point is determined by not only this fixed point, which is F, but also this line, which is the directrix, which is also known as line AB, from Pappus Book 7, proposition 238. So we need to develop an equation for a parabola. That's what this video is all about. So, we actually need the x and y coordinates for each point on the parabola. That's why we're going to develop an equation here. Okay. So, we're going to draw a perpendicular line from the focus to the directrix. That's what this line is all about right here. Okay? Alright. And it's going to be the y-axis of the parabola. And we're going to utilize the x-axis, and this x-axis is going to pass midway between the fixed point and the directrix. Okay? So the x-axis is above the directrix but below the fixed point, and it's halfway between these two, between this point and this line. Okay? Okay, now, what is the measurement of this line right here? Well, the measurement of this line right here is going to be 2p. That's what it's going to be. Okay? Because the distance from here to here is p, and the distance between here and here is also p. Okay. And by the way, this p right here is a lowercase p, whereas this one's an uppercase. Okay, this is a capital P, this is a lowercase p. Alright? The coordinates of the fixed point is 0 and lowercase p, and the equation of the directrix will become y equals negative p. And by the way, that's a lowercase p, not a capital P. So, okay. Alrighty. And why do we know this? Why is the distance of the directrix that way? Well, we're going to get into that in just a second. Okay. Now, according to the definition of a parabola, PF, which is capital P, capital F, that's this line right here, is equal to PD. Alright, now, where is P capital D? Let's see, where is capital D? Alright, I know it doesn't look this way, and that's fine, but they're saying that the distance here, and I know this doesn't look like this, but the distance here is supposed to be the same distance as this. That's what they're saying. And if I had drawn this out a little bit better, it would have. Okay? I just didn't draw this out as... It should have been a lot wider. That's what I'm trying to say here. That this point actually... as you can see here, if I was to draw this a little bit better, and I really didn't, and I'm sorry, and I failed, but let's draw this a little bit better. Okay. Let's draw this. I can make a goofy. See. But you can see how this is going to correspond. This okay. This is going to look a lot better. So we have to make some... This is also capital D. That's why I put Z and D, because Z was what it was in Pappus proof, but D is what it really is. This. I'm going to draw these in with green. Alright. This is the distance of capital P, and this dot right here is P. This is capital P right here. And if we wanted to get more specific, y minus P would be up there. Now this particular P right here is a lowercase. This was an uppercase. Okay. And by the way, this should have been, that's the Greek letter whatever. Anyway, that should be a little more accurate, I hope. But anyway, what they're trying to say is that PF equals PD. So this distance right here is going to be equal to this distance right here. Okay? I am so sorry about the screw-ups. Alright, and actually, if we're doing this correctly, that H should not be there. That H should actually be here. That's point H. Okay. Now, let me go ahead and erase this. Make this capital D. That's better. Okay, let's continue here. The length of PF is the hypotenuse of a right triangle. Okay, well, let's show you that this is a right triangle here. There it is. And now, the length of this right here, let me show you this. The length of this line from here to here is actually x. Okay, because you're on the x-axis, the length of this is from 0 to x, because that's what this is up here. Okay, the x-coordinate of capital P, this point capital P, is actually x. Okay, so this line is the length of x. This line here is y minus P. Okay, because the actual length, if I understand this right, okay, so we got an error here. These are lowercase p's. This is not a capital P at all. This is a lowercase. Let's make it like that. And these distances are also lowercase p's here. This is a capital P. This is a lowercase p. Now P okay. So the length of y here, from the x-axis to all the way up here, this whole length here, from here to here, is the length of y. Okay, so we're going to take this length away from this, and that's how we get this line right here. Okay, so that's why it's called y minus p, is because the whole length is y, and we're taking this p part out of it, and that's why it becomes y minus p. Alright, so far so good. Alright, so now we're going to set up the equation. So, what's the equation here? Well, we're going to erase all this out. I hope you're taking notes here because you're going to need them. So, what's the length of PF? Capital PF. That's from here to here. Is equal to the square root of, and this is by the Pythagorean theorem, which I taught in Euclid Book 1, proposition number 47, if you'll remember that. x squared, okay, because you got this length of x, you're going to square it, plus y minus p squared. And that's how you get that. Alright, so what's the length of PD? Now let me make sure you guys are still getting this. Whoa, that was bad. Let's see now. Okay, just barely, but you are getting this. Okay, the length of PD is as follows. So what are we doing here? Okay, we're talking about P capital D. We're talking about this. From here to here. What is the length of that? Okay, if we're establishing that PF and PD are the exact same length, which I know they don't look the exact same length, but they actually are in this figure. Okay, so what is the length of PD? Well, the length of PD is x squared plus y minus p, and that's lowercase p, by the way. Both of these are lowercase p. Okay. So what we're going to do is, since we know that the length of PD is the length of y plus the length of p, okay, oh yes, I can see that. Okay, I see that. Because what we're saying here is this is the length of y, and you're going to add this much more to make the length of p this. Alright? PD. So length of PD is the length of y, which is this, plus this extra length of p. So we have, okay, so we can replace this y plus p, and this is y plus lowercase p, because this is the lowercase p and so is that. We can replace this with PD. Okay? Following along so far? Now, we're going to square both sides. And I'm going to let you do this as a project. Okay? Now if we square both sides, you get x squared plus y minus p squared equals y plus p squared. And if you factor all this out, which we can do this, here, let's factor, okay, study that for a second. If you have to, pause the video. Alright. Now remember, everything in this equation is a lowercase p. Okay? Remember, these are lowercase p's here. All four of these are lowercase p's. And even that's a lowercase p. Okay? Alright. And if we were to solve this entire equation, this is what we'd actually get. That's what we finally get. Okay. Now for you guys watching me on the live stream, when this is over with, you can go ahead and watch my video and you can see what I actually did. Alright? And this is how we derive the equation of a parabola. Alright. If you have any questions, if you want me to do this over again, I'd be more than happy to do so. I think you guys can see where I'm going with all this. Alright. Well, thank you guys for tuning in. If you're watching me on the Easy Share video, I want to thank you guys for tuning in. Let me know what you think, and I'll read your comments and I'll reply back as best as I can. Thank you very much for watching this presentation. I will tell you more in a future video, so I'd like for you to stay tuned.